Hey, I'm back. All right, now we're doing video note 7 part 2, which is solving two-step equations. So this time we're doing two-step equations, which means that we're going to be doing equations that have two operations to be performed. Okay, so I still have my same just little colored pens because there will be more color coding in this video. Let's get started. Okay, I'm going to talk a little faster this time so that we can go on and get through this. If you don't catch on everything, of course, you can just watch the video again. Okay, so just like before, our goal is still to isolate the variable, which means to get the variable by itself. Just like before, we're still going to use inverse operations to solve. We're also going to end up basically doing PEMDAS. So remember, please excuse my dear Aunt Sally, which is your order of operations. We're going to do that backwards. So pretty much what we're doing is stagnant. And basically what we are doing is we are combining like terms. So we're going to combine like terms first. Sorry, I can't spell, people. All right, let's get started. Example 1. We have 6x plus 3 equals negative 27. So you see that we have multiplication and we also have addition in this. So that's what makes it a two-step because we're going to end up doing the inverse operations. So I'll just put a little chart thing right over here because I'm going to explain how we're going to do this. So since in the problem we have multiplication and addition, that means we have to use our inverses to solve. So therefore the inverse of multiplication is division and the inverse of addition is subtraction. So that means to solve, remember we're doing SATMIP, not PEMDAS. So that means we're going in the reverse operation. So since subtraction comes first in SATMIP, we're going to end up subtracting, then we're going to divide. So that's all that means. Okay, and the reason why we're going to subtract before we divide is because we're trying to combine the like terms first. So since basically this 3 and this negative 27 are like terms because they're both just numbers only. There's no variable attached. So that's why I want to remove that 3 first. So to remove the 3, remember I use this inverse operation with the subtraction. So first I'm going to subtract 3 from both sides. So now these 3's are going to cancel, leaving me with 6x equals negative 30. Don't forget your integer rules. Now since 6 is being multiplied by x and I'm trying to isolate that x, I'm going to divide. So therefore, I'm going to divide both sides by 6. So now my 6's will cancel and that leaves me with x equals negative 5. Okay, as before, we're going to check to make sure that our solutions are reasonable. So therefore, go ahead and plug in your negative 5 into the parentheses and solve. 6 times negative 5 is negative 30. Bring down the rest. Negative 30 plus 3 is negative 27. Since negative 27 equals negative 27, then it checks. I guess you see I have the word them written there, so that means you're going to pause the video now and do example 2 yourself, and we will check that in class. Okay, so let's keep it moving. Okay, we now have examples 3 and 4 on the right side. And I'm even going to be nice, and I'm going to go ahead and do example 4 for you, and you will do example 3, and we'll check it in class. So we have decimals in this example, but you should know decimal operations, so it should not be a problem. So let's see what you should do. We have 4 minus 1 and 2/10 b. So technically, this 4 is really being added to 1 and 2/10 b because it's a positive 4. And remember, we want to remove that away from our variable, so therefore it needs to go to the other side. So to do that, we're going to subtract. And remember, whatever I do to one side, I do the same thing to the other side. Now, since this 4 is a whole number and we're subtracting it from a decimal, remember, we got to line up our decimal points. So the decimal point will be here, and since 4 is a whole number, it will go under the 8. So now let's subtract. These cancel, and I'm left with negative 1 and 2/10 b. I know y'all ready to just write 1 and 2/10. Think about it. If I was to cover this up, you still see that negative sign. The negative is attached to the variable term. And when I subtract over here, I get 14 and 4/10. Now, since the negative 1 and 2/10 is being multiplied by our variable, I want to divide to remove it. And I must divide by negative 1 and 2/10, since that is what is in front of the variable. Because remember, if I don't, then I'm still left with a negative variable, and we don't want a negative variable. So these cancel, and I have b equals, oh boy, and now we are dividing decimals. So remember how to divide decimals. So let's come up here to the side. You're going to have to write small. Now let's just forget the positive negative right now, because we already know that a positive divided by a negative is a negative. So we have 1 and 2/10. Remember, Ned and Donkey divided into 14 and 4/10. So since I need to move my decimal point 1 time in the divisor to make it a whole number, then I also need to move my decimal point 1 time in the dividend to make it a whole number. So we're actually just dividing 12 into 144, which you should know is 12. So b equals negative 12. Let's check. Substitute negative 12 into your parentheses and solve. So we basically have 4 minus, and when I cover that up, I see 1 and 2/10 times negative 12. So you know that's going to give you a negative answer. Now come over here and multiply 1 and 2/10 times 12. And you basically know that 12 times 12 is 144. And you're going to need one decimal place. I'm going to put that in parentheses. Right now, 18.4. Okay, now notice we have our double negative. And what happens to the double negative? Such smart babies. It becomes a positive. So what we actually have now is 4 plus 14 and 4/10 equals 18 and 4/10. And since 4 plus 14 and 4/10 is 18 and 4/10, then 18 and 4/10 equals 18 and 4/10. So that does check. Yay. Okay, let's go to the back side. In example 5, notice we have our two operations are division and subtraction. So in the problem, we see division and we see subtraction. Their inverse operations are multiplication and addition. So remember to solve, we're still doing PEMDAS in reverse order. So we're doing SATMEP. So what that means is, since the addition comes before the multiplication, then that means we're going to add, then multiply to solve. Okay, so let's come over here and solve. Okay, since I first want to remove this 6, we've already said that we need to do its inverse, which is addition. So first we're going to add 6 to both sides. Negative 4 plus 6 is 2. And what I'm left with on the right side is z divided by 5. Because those cancel. Excuse me. So now I need to isolate the variable by doing the inverse of division, which is multiplication. So therefore, I'm going to multiply both sides by 5. So remember, I just kind of like to rewrite this so you can see exactly what it was and what it becomes. So we're going to put both these in parentheses and put a 5 on the outside to show the multiplication. So these 5's cancel, leaving me with z. And 5 times 2 is 10. And I didn't leave us enough space. Remember, we never want our variable on the right side, we want it on the left side. So just switch sides and you have z equals 10 box. Okay, let's check. So substitute your 10 into the parentheses and solve. So we have negative 4 equals 10 divided by 5 is 2 minus 6. So negative 4 equals 2 minus 6, which is negative 4. So since negative 4 equals negative 4, it does check. I'm so sorry. I forgot to move the paper up. Okay, you're going to pause the video and you're going to do example 6. Okay, we will check example 6 in class, so please make sure you have it done. Let's go to example 7. Now, in example 7, I want you to first take that 5 that was there and change it to an 8. Because if we don't, we're going to end up with more than a two-step equation. And that means we need to change this 5 to an 8 as well. Okay, let's solve. Okay, now remember we talked about you have to combine like terms first. So in this problem, my like terms, excuse me, are my variable terms, which are the numbers with the variables attached. And then we also have constants, which are just numbers by themselves. And since both of the like terms are on opposite sides of the equation, that means I'm going to have to do the inverse operation to move them together. Because I want everything that has a z attached together, and I want everything that's just a number by itself together. So therefore, I want to move these 8 z's to this side. So what I need to do, since they're being added over here, because that's positive, is I'm still going to do the same thing, which is subtract. And I'm going to subtract from both sides. Now the way that we subtract this is basically we see 9 minus 8. So 9 minus 8 is 1. And you would just bring down the variable. So I still have minus 4 over here. Bring down my equal sign. These are gone now. So what's left over here is that negative 20. Okay, and 1z is just z, so we really don't even need that 1 in front of there. So now we have a one-step equation, and we will solve it by adding 4 to both sides. So the 4's are going to cancel, leaving me with z equals negative 16. Okay, let's check. So we're going to have to substitute negative 16 into both parentheses, because that's where our z's were, and solve. Okay, we have 9 times negative 16, which we know is going to give us a negative. Now move over to the side and multiply 16 times 9. That gives me negative 144. Minus 4 equals Now we have 8 times negative 16, which is going to give me a negative as well. Move over to the side and multiply with 16 times 8. And bring down your minus 3. Okay, now I need to combine my negative 144 minus 4, and that's going to give me negative 148. And negative 128 minus 20 also gives me negative 148. So, it checks. Okay, let's go to example 8. Now, in example 8, we have kind of a special situation here because we have a whole entire variable expression in our numerator that's being divided by 3 here. So in this case, we actually want to go ahead and remove that 3 from the denominator first. So therefore, we want to go ahead and do the inverse of the division, which is multiplication. So I'll start off by rewriting this. And since I am multiplying both sides by 3, I'm going to put these in parentheses and put a 3 on the outside. These 3's are going to cancel. And now I'm left with w minus 5 equals 36. So now to isolate my variable, I need to add 5 to both sides. The 5's cancel. So my solution is w equals 41. Okay, let's check. Substitute 41 into your parentheses and solve. 41 minus 5 is 36. It's still over 3 equals 12. 36 divided by 3 is 12. 12 equals 12. So that does check. Okay, you're going to finish off by doing example 9, and we'll check it in class. And I'll see you in class with video note 7 on Monday. Have a great weekend. Bye-bye, babies.